I Adharsh
I Adharsh.
are going to be presenting our project for Viksit Bharath 2025.
So our project is a dual axis solar tracker. So it detects light where the nearest light is coming from. We have used many components like servo motor, LDRs, and jumper wires, Arduino Uno.
So the uses of this project is to make a constant source of energy by attaching a solar panel to this motor, so that wherever the sun is, it tracks the star accordingly, and it can get a constant source of energy without any disparities. So potentially this can also be used for tracking stars, for tracking constellations, for horoscope and all. So this can solve many problems, because people in the rural areas, they do not have like a constant energy source, and they have they are, since they are like poor, they can't afford to afford electricity. So this is a very cost effective solution, and it can help, as it can be used as a constant energy source for the electrical appliances in the home. So our teammates are Yashas and Samarth, and they have contributed a lot for this project, with materials and stuff like that. And this is the code that we use. So this is the code that has been coded into the Arduino Uno for the
Wait, yeah.
So, like I said before, this is the code that we have been using in this Arduino, and the program. This is the program that has helped the project to be a success. And yeah, so this is the project that is going to be a very. It's going to impact the world in a really good way. So this is the name of our project, Digital Jantar Mantar, reviving ancient astronomy through modern technology. So the aim is obviously clear, and the objective which has been listed here, to recreate a scaled down model of ancient Jantar Mantar instruments like the Samrat Yantra or Jaiprakash Yantra, using modern sensors, microcontrollers and software to track and visualize the sun's and the star's position in real time. So as you can see in this is how it has been built, and obviously in the day it will be tracking the sun's position, and in the night we will be using a telescope to focus the star's light onto the area to track the star's position. So this is the concept which we had thought of, but obviously, like I said in the previous presentation, it wouldn't turn out the same way. But as you can see over here, it has turned out somewhat similar. So, what we'll be using, of course, we'll be using a telescope, like it's like this picture. We'll be using the stars light. The stars light will be focused through the telescope onto the area, so that the area will get activated and just move according to the star's position. As the Earth rotates, even the stars will also go towards the west side. So next slide. So the components which we will be using in the night are a telescope lens tube. Like I told before, it focuses the light from the stars so that the sensors can detect it. And then the low light camera. We will be using the low light camera with the sensor, because it should be able to detect stars like Vega and stars.